All right. Go ahead, David. Dave.
Okay. So, welcome to the March 28th, actually 29th session of TangerineSDR and a ham-side technical session. My name is Dave, KV0S, and this week I've been doing a number of small projects and cleaning cleaning the shack, organizing. I still have a long way to go, but it's a start. So that's it for me. I did watch the Hamsai program last week and found it very interesting. And several of the talks surprised me, the ones that I was actually most interested in. So very good. So next on the list, Nathaniel, you want to give your report now?
Sure. Thanks. It's been a very busy week. I think we had a successful ham-side workshop. I was very happy to see so many people there in person and online, and I think that went really well. So now I'm trying to close out of all of the things that we need to do to wrap up the ham-side workshop and start moving on. So we're starting to get ready for a Hamvention. So I've been talking with Scotty and Word Silver and people like that. And of course, we've got a number of projects going on with Bill Engelke and others as well that we're moving ahead with. W2NF, back to net.
Very good. Next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Well, good evening to you, Dave, and good evening to the net. As far as this project goes, about the only thing I have to report is I worked out a way for the grape to upload to the central control system in such a way that when it gets to the central control system, it gets pushed back to the ham-side server on the back end. My students have a watchdog feature that will notice when such a load comes in and will add it to the database of observations. We're going to work on that some tomorrow. So I have tested that on a grape. That is the grape set up for running GNU radio and saving data in digital RF format. So we're making progress on that slowly but surely. Okay, back to net.
Well, very good. That sounds like progress. Next on the list is Bill N8ET. Go ahead, Bill.
Yeah, I don't have too much to report here. I've been stumbling away on my income tax, and we're just about done. So that's good. And I'm coming out on the right side of the income taxes, so I should get a little money back from the federal government. But California's eating my lunch, and so's Ohio, I think. So probably not about even. So that's about it from here.
Okay. Next on the list is Dan, N4XWE. Go ahead, Dan.
Oh, thank you, Dave, and good evening, everyone. Well, this week I started working with Bill to create a script that will ultimately download, compile, and configure the TangerineSDR code. Didn't have quite enough time, the same amount of time to work on it as I thought I would have earlier, but I'm slowly moving through it. I'm probably halfway through. Everything seems to be working okay. And I guess that's about it. Back to you, Dave.
Well, fine business. And next on the list is Dave, KD0EAG. Go ahead, Dave. Oh, still I can't hear you. It looks like your mic's on, but I'm.
Must be one of those many adjustments in Windows.
Well, I don't do Windows.
There, you got it.
Yeah. No, this is
It was a volume.
well, no, it was just the wrong, it just needed a boot
Okay.
in the right place. No, I enjoyed the workshop. I got home, been getting things kind of together a little bit, not tremendously. And but I'm plugging away at several projects. Nothing real exciting. That's it for me.
Okay. Next on the list would be David in one HAC. Go ahead, David.
Good evening to the net. Been decompressing from the workshop, but boy, that went well. And working on some South Pole stuff and various other radio thingies. And the one question I have for the cloud is, will the talks be posted? Because I ran into Mike Trimpey, and he'd like to be able to see the talk where I was using his name in vain. Back to net.
I believe they're posted, but we'll have to wait for Nathaniel to get back.
Yeah.
For a detail.
I hadn't seen that they were linked yet, but maybe they are.
Next on the list would be David Wahl, KE8 QEP. Go ahead, David.
Well, hello, everyone. I have, as far as the magnetometer goes, I still have that other board to install. But because of the flooding issue in the backyard, mostly actually because it makes the dog extremely muddy, we've begun to remediate, or getting estimates for remediating the water in the backyard so that I can have this magnetometer in there. So it may end up costing as much as professionally installed magnetometers after you get the water removed. So I'm still working on that. And other than that, I'm making a 6-meter halo antenna. And I think that's about it. So back to group.
Sounds interesting. Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Been working on a little project here. I live in a homeowners association restricted neighborhood where we're theoretically not supposed to have antennas up. So I installed an anemometer on top of an aluminum tube, which just happens to be a quarter wavelength, 20 meters. So that's how I got around that problem. But I got to bury the feed line. But in reading the rules, it's kind of interesting. Aside from restrictions on antennas, there's also a statement in there that we're not allowed to dig more than 1 foot below the surface, which would be a problem for magnetometer, I suppose. But again, if you dug a hole and put a magnetometer in and filled it back up, who would know, I guess. But that's just an interesting point. I never heard that one before, but that's about it. Back to net.
Well, interesting. Next on the list would be James Wolford, KG4 DSG. Go ahead, James.
You got audio?
Yes.
Okay. Evening, Dave and group. Nice to see everybody back from the conference, even though I had other plans. I missed it all. I would like to second the request to put them up online if they're available. Other than that, not much else going on around here. So back to the net.
So Nathaniel, while you were gone, there was a question if the talks have been posted anywhere.
So the short answer is no, because they are being edited by Jason Johnston for Ham Radio, from Ham Radio 2.0 for his YouTube channel, and they're going to go up there. But the longer answer is I will be glad in a minute to post the links of my raw Zoom recordings in the chat, and then you are welcome to look at them there on your own time until the actual ones get up on YouTube. How's that?
Sounds good.
Sounds good.
Great.
I hope you get a quicker response out of Jason.
Yeah, he said he was going to do it faster this year. I
we
mean,
have some
last
meetings for Tapper that he recorded, but I've never found them.
Yeah. Well, I mean, last year we had the YouTube live ones up right away, and we did that. And this year and so I didn't, chase after him too much.
Yeah.
But I figure this way, like anyone who just emails me or asks me, I will send you the Zoom links while I have them, and I'll have them for a while, I think. And that way, people who really want them, they can have it.
Okay. Next on the list is Jay, WB8 SBI. Go ahead, Jay.
Yeah, good evening, everybody. I second the motion for the links, if you would please, because I have my colleague, Whiskey Delta 8 Mike November X-ray, who was supposed to go with me, but unfortunately due to work could not attend. But he's really geeked to see everything and is already making plans for next year. So other than that, not a whole heck of a lot new for Hamsci. One of these days, maybe at Hamvention, I can, and over in 807, I can tell you the story of all the crazy drivers that nearly caused me to have a 911 event on the drive down from Detroit there and on the drive back. Other than that, looking forward to seeing everybody at Hamvention and at Tapper, at the Tapper DCC. Other than that, nothing much new here. 7-3 to all, and see you all at Dayton. Take care, stay safe. Back to net.
Okay, next on the list is Jim, K4BSE. Go ahead, Jim.
Well, good evening. I too am anxious to look at the recordings of the event. I missed the first morning because it conflicted with Grandparents' Day at our granddaughter's school. So you know who won that one. But I still am looking forward to going back and catching up with them. Enjoyed the ones I did catch later. And let's see, I had a little time finally today to look back at the Tonga data a little bit, and I decided to see what I could do if I looked at the time, not only the estimated time of arrival of something from the short path, but also the long path and the short path second time around the Earth. And the only data I had that went out far enough for that was my own. When I looked at the likely spread of time where I should have seen something from the long path, yes, there was some interesting stuff happening. Now, like the short path, yeah, there was stuff before and after that too. So tying it down to Tonga was kind of difficult. And the second time around the world, it was not as clear that anything was going on. Other than that, that project I mentioned a couple of weeks ago, that was a 4-hour project that is currently 80 hours and counting, is still counting. And I'm going to have to spend some time on that on the next couple of days. Other than that, let's see. I noticed my great data for today. I was interested with all the activity on the sun. If there was a lot of stuff going on today that was looked unusual. So I was anxious to pull up the chart that was finished an hour and 13 minutes ago, and does show a few interesting things, but doesn't leap out at me at a really super busy day, although there's a little bit more than a calm day. Otherwise, back to net.
Well, fine business. And next on the list is Joe, K7LUX. Go ahead, Joe.
And hold on, Dave, the links are now in the chat. So anyone who wants the Hamsci workshop raw footage links, you can grab those links and bookmark them.
Okay, I guess it's my turn.
Yes.
Good evening, everybody. Still recording great data. I have a request for the group. the club is, my club has been, or our club has been tasked with providing a amateur radio or an amateur radio demonstration for the annual STEM celebration. And if anybody has any spectacular pictures of ham-sci in action, rocket launches, I've got some balloon launches. We used to do that here about 10, 12 years ago. But sure, look at others, or any kind of picture we could hang on our display boards to indicate how a person gets involved, what kind of activities a person can get involved in. This is K through 12, K through 12. So we're appealing to a bunch of people who like things that go bang or go whoosh into orbit or something like that. So if anybody's got any pictures, please either post links on the chat group here or send me the links or pictures at w7lux@arrl.net. I'd sure appreciate it. That way we can get some more ideas out to the local people on what they can do with science and amateur radio. Thanks. Thanks, Dave.
Sure thing. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It was a fairly busy week for me, so I didn't really get much done. But there were a couple of things that I wanted to mention. EBSynth, the digital synthesizer and modulator program for EBNOT messages has been tested. The newer version has been tested by a bunch more people with a lot of positive results. I would advise anyone interested to go to the VLF group on groups.io for more information, or just look up EBSynth on Google and you'll be taken right to the webpage. Also, I've been adding parts to the parts list for my EBSynth rig, and that's going to be, I hope to do a separate presentation at Tapper about EBSynth and EBNOT and amateur communications below 9 kHz. Also, I really enjoyed the ham-sci workshop. Congratulations, Nathaniel, for all your hard work and effort. It went really well on the virtual side anyway. Someone contacted me about my presentation and about my work, and hope to correspond with them more. I also contacted Monty Bateman to get a better idea of what his focus is on his lightning study. Apparently he was looking for something that can do direct sampling in the gigahertz range to do his higher resolution lightning mapping. Also, Jay, I believe it was you that asked a question during Tamitha Scove's presentation on how to receive spherics, tweaks, whistles, and chorus. You were wondering if you could use your amateur receiver to listen, and the short answer is no. You'll need to build a VLF receiver like the one that I installed at Nathaniel's QTH. I haven't been able to receive a lot of any whistles and chorus yet, but I have gotten a lot of spherics and tweaks. There's some harmonic noise that Nathaniel and I will eventually address, and hopefully whistles can come through. But yeah, the short of it is they have to build a VLF receiver, and you have to be in a fairly hum-free location without any sort of mains harmonics. Things could be filtered out, and you could actually hear these signals and automatically detect them with the VLFRX Tools software.
What frequency range? What's the frequency range?
Oh, that's definitely below 9 kilohertz.
It's audio,
the,
Jay.
Yeah, audio. It's usually around 5 kilohertz is the center of the band for whistles and chorus. So it's a really low. That's why you need a special VLF receiver. Other than that, that's all I have. Back to the net.
Well, fine business. And next on the list is Jules, K2KGJ. Go
Hi,
ahead,
group.
Jules.
Not a lot to report this week. Just a number of projects going on here, but I did happen to discuss with Jonathan a find, and I totally forgot about. I had an RF Space SDR IQ receiver, which covers well down to 500 hertz, which would be an ideal VLF receiver with decent sensitivity, a little preamp ahead of it, and hoping to set that up in the next couple of weeks. But that would give me VLF capability, and but hopefully the environment isn't too bad in terms of harmonics. We'll see of the power line. We'll have to try that out yet. Anyway, that's about it here. I've been talking with Dave Witten a bit about magnetometer stuff. Other than that, not much more to report. Back to net.
Well, fine business. Next on the list is Michael, AA8K. Go ahead, Mike.
Well, thanks, Dave. Greetings to everyone listening, and back to you.
Nice to have your face and voice back.
Oh, really?
Yes.
I'll put the gory details in the chat.
Okay. Next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Oh, hello.
Yes.
I can talk.
Yes.
You can't hear me, right?
I can hear you.
That's too bad. Okay. Aside from that, I've been pretty busy a couple of weeks here. We did, and I don't remember where we left off the week before, but we've got the magnetometer mass production. All the parts have been ordered. We had two shortages. One was the NXP part, which we all knew about, and that's supposed to come in May 3rd, I believe, is scheduled. It's been ordered, so it's on the books waiting to be shipped whenever they get them. The other part, we fiddled around too long and the temperature sensors went out of stock, so we had to make a substitution. And we talked a little bit about that. I think Dave, KD0EAJ, and Jules, we talked a bit about using the 9804 instead of the 9808 temperature sensor. Well, it turns out that Microchip had 1,000 of those, but when we went back to buy them, they were gone. So now we don't have any temperature sensors. Well, we didn't. We managed to find 400 of them at Online Components. So we ordered those. And so the question then really is, I guess I have a question on this. Do we really need a local temperature sensor on the board that plugs on the Raspberry Pi? So if we do, if we want to make them the same board, then I can build 400, 200 sets and we will be fine. Well, we've ordered the remaining 100 temperature sensors, but they're not going to be until October. So I'm not going to hold the build up. I'm going to go ahead and build 200 of them, 200 sets. But if we don't need a temperature sensor on the inboard end, on the Raspberry Pi end, we'll just not install that, and then we can build all 500 cores.
Yeah, Scotty, this is Jules. I don't think we do, but I'll let Dave be the final arbiter on that one. But as far as the local end goes, I don't really see the need for one.
Yeah, I was curious as to whether we even use it or not. So, so we can chat more about that in the general discussion. Let's see. So we're going to go ahead and order the PC boards for that. So we'll have everything in hand, ready to go when that last part comes in. And with any luck, it comes in early enough. I may have a few that I can bring to Hamvention in May. We'll see. That's cutting it pretty close because I leave like on the 12th. So it gives me like 10 days, 9 or 10 days to test a few boards to put them, get them ready to sell. On the RF module and clock module front, both the clock module and the RF module are due, the prototypes are due Friday, the 1st of April. And we had a shortage on the RF module. We couldn't get one of the voltage regulators, so we made a substitution, and we made a wrong substitution, and we got the wrong package. So the RF modules were stopped. However, we managed to find, believe it or not, I can't believe I could still find this. We found a TI part, a substitute for the microchip part. It uses the same package, but TI's package for the SO or for the MSOP 6 is slightly different dimensioned than the one that microchip uses. But it turns out it will fit on the pads. And so we ordered those and we were installing those. Now I want to talk to, I see Tom is here. It's the capacity of the new regulator is significantly less than the old one. It's only 150 mils. The old one was 300. However, the only thing that we drive is the RF amplifier, and it's rated at 90 milliamps. So I think we'll be okay. We'll chat about that in the general session 2. The clock module, no shortages. It uses the same regulator as the RF module, but we did the proper substitution on that one, so we have the correct parts for that one. And if I'd only bought more of them, we could have stolen from that board and we'd have enough to do the other, but we only bought 5 extras, so we didn't have enough to steal them away from the clock module and put them on the RF module. Anyway, at the end of the week, both of those will be done. The data engine adapter, I finished that up now, and I sent that out to a few folks on here to take a look at. If you get a chance to look at it, that would be great. More than one set of eyes is always good to catch obvious dumb things, mistakes that I might have made. It's in layout, and we actually, right before the meeting here, I got a note from the CAD guy, and if I could share my screen here. This is the read-in that we get. Okay, now you can see that it's all it is a rat's nest, and all the parts are on the board. This is not the final form factor, obviously. This just proves that we can read in all the decals. So we got a good read-in now. Tomorrow I'm going to get with him, and we're going to expand this out to be the proper size board and make sure everything will plug together. And he's going to read in the data of the RF module, the clock module, and we're going to make up some fake DK boards and TI boards that this plugs onto, and we'll plug the stack all together and verify that we can that it'll plug together and not physically interfere with anything on any of the boards. So pretty busy, I guess. One other question I have for the group is, since we're going to be making these adapter boards, I need to know how many to make, and there's not much point in making very many more of them than we have DK boards. So as to the group, I'm asking how many DK boards, 1, 2, or more that you have. I think I've got 2. I have 2. Nathaniel has 3. George has 1. I don't know how many Dave or Tom have, but if you could let me know. And anyone else who has a board, let me know, and I'll put it on the list so I can make sure we get. Okay, I see David has 1. And 1 HAC. Okay.
Correct.
Anyway, let me know, and I will add you to the list and make sure we have enough adapter boards to go around for everyone. That's about it.
W7LUX has 1.
Okay. Okay. How many do you have, Dave?
Dave, me?
Yeah, you did.
Yes, I have 1 of the E and 1 of the D.
The DK board is what we're talking, the Max 10 DK board from DigiKey.
Oh, I only have 1. Sorry.
1, okay. Now, I don't know if Dan, do you have one of those?
Yes, I have 1.
Okay. Okay, that's it. And just need to hear from Tom how many he has, and we'll be good.
Well,
So what's the total so far?
6, 7, 8, 9, 10. 10 plus whatever Tom has.
1 from Tom.
11 boards.
So are you done, Scotty? Can we
Yes,
hear from
yes,
Tom?
go ahead. Thanks, Dave.
Tom?
Good evening. And
Go ahead.
Nathaniel, I want to say thank you for the ham site conference. It was great.
you.
Excellent talks. Super good job. So thank you very
Thanks.
much. Scotty, I got your email with all the schematics. I'll review those tomorrow. Today was income tax day.
Oh,
And tonight will probably be something depressing evening. And but I'll look over all the schematics. I'll have to look at the RF part that you talk about on the receiver module. Is that the ADC driver chip? Is that what you're talking about?
no, the part is the 3.3 volt regulator that powers the RF amplifier, the ADC amplifier.
Okay. So I just need to go track down the current consumption of that ADC driver chip then.
Right, and that's a single chip that drives both ADCs, right?
Yes, it's a dual driver chip.
Okay, 'cause I looked it up and it came in at like 93 milliamps maximum. So
okay.
I'm hoping the 150 milliamp regulator is going to do it.
Okay.
Unless there's something I didn't see. That's the only part I can see that's being driven by that 3 volts. So
Yeah, the whole ADC chain, gosh, I haven't looked at that schematic in a couple of years now. So I don't remember what runs on 3.3. I think most of the ADC chain ran on 1.8 volts.
right, it does. And that was one of the schematics I sent you, was the Rev A, the actual one for the board that we're building.
Yes. Well, I'll go over that in the adapter board with a highlighter and a ballpoint pen.
Okay, great. Thanks.
So, Tom, I wanted to say, welcome back.
Thanks. I've been working on a couple of other projects in the meantime, so it's been busy. And they're novel projects and they're all on back order, and back order's been delayed and pushed to more back orders. So, so it doesn't matter what project you're on, whatever it is, it'll be on back order.
Yeah. Well, that brings us to the end of the list. So unless I missed somebody, we're open for general discussion.
So I was going to say, Joe W7LUX asked for some photos. If you go to the Hamsci workshop page, I have a photo album up from the Hamsci workshop it's on the agenda page. So I'll put the link to that in the chat right now. And then another possible place to get photos is there have been a number of posters that have been done. I know like Jonathan Rizzo's poster has some photos of him and me digging trenches. I don't know if that's exactly what people want to see, but it certainly is activity related to what Hamsci is doing. Also, some of the other students may have posters as well. And then Joe, I know your poster from AGU is a possible source of photos also.
Right. Got that. Thank you very much, Nathaniel.
You're welcome. And all of the posters from the Hamsci workshop are on the agenda page as well. You can just click on the title of one of the posters and you should see the poster.
Say, Joe? Joe, can you hear me? This is Jules. Yeah.
Yes.
This isn't really Hamsci, but how about balloon-borne whisper transmitters, which are ham radio things, but and still fall into citizen science regarding propagation and ballooning and so on and so forth. That's another possibility you could think of.
Right. I have, and there's an English ham who did some work with Whisper to locate that mysteriously disappeared flight over the Indian Ocean about 8 years ago or so. But I don't know if it's valid or not, but he made a guess as to where the debris might be found.
Yeah, it's fairly easy to send up a helium balloon with a very, very, very lightweight whisper transmitter and have some fun with it too.
Well, we've sent up heavy duty weather, I mean, not weather, but high altitude balloons here. Got
Yes.
some pictures of those.
Yeah,
So
right.
that works well. Okay, thank you.
Scotty, the spec sheet for the ADC driver says the current consumption is 80 milliamps typical per amplifier. So the package would consume typically 160 milliamps.
What is the part number?
LT 6420C-20.
Okay. Yeah, because that also isn't going to necessarily account for power to a load.
Yeah, it just says power supply current is typically 80, max 95 per amplifier.
Right.
That's a pretty close to me. I don't like that. I mean, I don't know how much this regulator what it will do when you overload it. 10 milliamps overload. 160.
Yeah, my worry, of course, is if it gets noisy on the output, that's really bad.
Right, right. So, but the fact is that there is basically no other regulator I could find that would fit on that footprint that we could use that I could get in any kind of reasonable time frame.
Yeah.
So I could check with them because we do have 5 extras on the clock module that are the right side. There are, I think they're 500 milliamp regulators.
Mhm.
And so he could build 5 of them with those. And the problem is the 3.3 volt regulator on the clock module supplies the GPS units, and they draw about 250 milliamps. So you can't use these light duty regulators on the clock module.
Yeah.
So
What did you say the part number was? I think I got it wrong.
LTC 6420-20.
Oh, LTC. That's where I missed it.
Hey, Tom, could we run those regulators? I mean, those amplifiers on 3 volts instead of 3.3?
Yeah, I think so. Because
I think I can find a 500 milliamp regulator at 3 volts.
Okay, I've got a, hang on, I lost the data sheet here. Let me check the DC specs here. Power supply, typical, they can run from 2.85 to 3.5 volts, and typical is 3.0.
3.0. So okay, so if he hasn't built them already, I may be able to hold him off to okay, that's all I need to know. Thanks.
Okay.
What's the regulator number, Scotty?
NCV Nancy Charlie Victor 8705. That's the one we spec'd.
Right.
500 milliamp regulator. The one that we bought. Oh, you're going to ask me that. I'm going to have to. Oh, it's an LP 5900.
Interesting.
Papa 5900, and that is a micrel part, I believe. But it's 150 milliamp regulator. So yeah, it's the LP 5900 SD-3.3/NOPB, no lead. So that's the one we put down. The other one, let's see. NCV 8705. See if they've got any. These are fixed regulators. They do make an adjustable one, but we can't use it because we didn't bring the pin out, and it's MSOP, so there's no leads, so it's not possible to. But I did notice that they had some other fixed voltages. And they have lots of them in the wrong kind of package. Okay, so there is a 2.8 volt one that we can get. There's a 1.2, which is not obviously not going to work. And let's see, that's another 1.2, 1.2, another 2.8.
2.8 is a little bit out of spec.
Yeah. 1.8, 3.3 in the wrong package. Nope. 2.8 is the only other one I could get. That would be a 500 mil part. I'll look a little bit further and may be able to find something else, but at first glance, I don't think that they make a 2.8 version. I mean, a 3.0 version.
Okay.
That's,
Yeah, yeah, 3.0, 3.3. I think all of those are okay. I'll have to check for any voltage dividers that might come off that.
yeah, because I think all I saw was just pull-ups. And then, of course, the power for the
Yeah,
part itself.
Yes, there are 2 voltage dividers that come off of that supply. And so if we change the voltage, we'll have to change some resistor values.
What the other alternative would be that we could only use one amplifier at a time for our testing. And that would.
Yeah, but then, yeah, that'll require cutting some circuit board traces.
Well, if we don't put an input signal in, is that going to?
Yeah, the amplifier, there is an enable for each channel.
Okay.
And the enables are hardwired on the circuit board to the enable position.
And they're not with pull-ups, they're hardwired, right?
Let me see. They're hardwired, no pull-ups. They're ground to enable. So the enables are just connected directly to ground.
Okay, so that's not going to work. Well, depending on, I guess if we did it before we put the part on, it might work.
Yeah, the resistor set the common mode range of the amplifier, and if you and right now the 3.3 divides it down with a 1.2K and a 1.0K to get the right voltage. If you change that to 3.0, we're going to have to change a couple resistors.
Okay, which we can do if we had to, but it doesn't look like I can get a 3-volt regulator anyway, so I guess it's moot.
Okay.
They do in fact make one, but again, no one has one, so that's not surprising. And the package types are vastly different, so they're not going to be usable.
Yeah, David, the note on the driver says that it has low impedance outputs, and so unless you heavily resistively load the outputs, there's not much output current in the amplifier.
Which means even if we lightly load it, we're not going to save much then.
Yeah.
Well, the question is, what's the input impedance of the ADC?
The input impedance of the ADC, let me check. I've got it set. I capacitively couple from the driver outputs, and then there's about 100 ohm termination resistance. Then that feeds the ADC.
Right, but the ADC probably has a finite resistance as well.
Yeah, it does. But
and yeah, if you're driving that load, it's going to have some significant current. Might be on the order of 25, 50 milliamps.
Yeah. All I can say is the data sheet says that, well, let me find the quote in it, but it said even with low output loads, the amplifiers don't draw much additional current.
Right. Yeah, I understand that part. They're class A, basically.
Yeah.
But what's the ADC?
The ADC, hang on, it's a dual ADC. It is the AD 9648.
Oh yeah, I recognize that.
Yeah, and there's
There it is.
So there's the on the driver, there's no DC load. It's all capacitively coupled.
Right. No, but I drive 50 ohm lines a lot, and it, 2 volts, say 2 volts RMS, it draws a fair amount of current. Let's see. Okay, its impedance is pretty high, 7.5K differential. So that's not going to be significant, but the 100 ohm termination will.
Yeah, I've got it. I've got a fairly low termination. I wanted to make sure the ADC was seeing a well-matched input.
Right. And it's looking for 2 volts peak to peak. So that's 1 volt each way. So 1 volt on a 100 ohm resistor.
That's about, about 10 mils?
Yep. So most
Any
of it's
rate,
going to be the amplifier itself.
Yeah, so at any rate, each amp is about 80 milliamps typical. So, when you put in the output drive and everything, probably going to be close to about 200 milliamps.
Yeah. Unfortunately, the LP in 5900 won't do it.
The other thing that we might be able to do, this is kind of hokey, but what else does the 5 volts drive on this board besides that regulator?
The 5 volt drive the relays. Hang on, it drives, let me see.
And the I2C expander.
Yeah, it drives the 6 relays, the 2 LEDs, and all of those the relays consume quite a bit of current. If you have them all on at the same time, they take quite a bit.
What I was going to say is the regulator is the power dissipation is the limiting factor, and that's determined by the voltage in versus the voltage out. So if we could reduce the 5 volts on that particular regulator, perhaps by putting a resistor in place of the inductor, L2, it may be able to reduce the input voltage to 4 volts, and therefore cut the power dissipation in half, which means you get more current out of it.
I guess, you can try taking the inductor up off the board and seriesing a resistor with it, kind of make a tent out of it or something.
I know we've done that before and that's a big inductor too. That's a 2012. So that could be possible to do that. I know on the HPSDR on the power supply, we did that. We put a series resistor because the regulator could handle the current, but it couldn't handle the power dissipation because the delta V was so high. So we put a dropping resistor in and just basically move some of the dissipation into the resistor from the regulator, and that actually worked.
Yeah, of course, that regulator's it's only dropping 1.7 volts.
Right. But it is an LDO.
Yeah, I'm guessing its dropouts in about the 1 volt range.
Oh.
I don't know. I haven't looked at that spec sheet in yours.
Yeah, well, I'm looking at the regulator that we replaced it with, and what's the overhead voltage is. They don't want to tell. 80 millivolts dropout.
Oh, that's pretty small.
Yeah.
So does it have a current limit in it? I mean, some of those parts have current limiters built in.
Yeah, and I don't know because they talk about power dissipation and all that, but typically they talk about it as far as derating it because of power dissipation. So I don't know. It doesn't say that there's a specific, it says calculate the power dissipation and then calculate the thermal resistance and see how much power you can actually dissipate in the device. So good question. I don't know.
Yeah, so let's noodle here. If we consumed 100 and if we consume 200 milliamps, which is probably generous, and we won't use quite that much.
At 1.7 volts
times 0.2 is 850 milliwatts.
Yeah, and then, well, wait a minute. At 200 milliamps at 1.7 volts.
I'm sorry. Let me use my calculator here.
Yeah, that's what I did. That's,
I'm sorry, 340 milliwatts.
340 milliwatts, and the normal at 150 milliamps at that voltage, it would be 255 milliwatts.
Yeah. Yeah, the package was picked to have a tie right to the ground plane as a thermal pad.
Right. So that is the best part for high dissipation. But let's see what the thermal rating is. Okay, for the junction to ambient, it is 79 degrees C per watt, and you've got 125 degrees maximum junction temperature. So you got 100 degrees to play with. So I mean, you could do over a watt if there's no current limiter in it.
Yeah.
If there's no current limiter. But then you scroll down, you look and you see maximum here, short circuit current limit, 300 milliamps.
Juice that thing.
That's at 6 volts input, and the output shorted. And they, of course, they don't tell you how long you can do that for. Probably not very long.
Where do you see the 6 volts part?
And the note down below, note 7.
Oh, note 7.
5.
Okay. So otherwise, they're saying V in equals V out plus 1 volt.
Yeah. But we would have 5 volts on the input, and we're not going to short circuit it anyway. It's just that we're going to just try to dissipate 340 milliwatts instead of 250. But even that, I mean, at 79 degrees C per watt, a third of a watt, you're talking about what 25 degrees C rise from ambient. So if ambient's 25, so 50 degrees C junction temperature, that's easily doable.
I wonder how well they share current.
The amplifiers, you mean?
No, the regulators. I will admit I've piggybacked chips if I needed more power.
Yeah. Good luck piggybacking a JSON chip, though.
They were dips.
If it gets down to that, we can replace these chips when we get the real ones, but I don't, that's a long time from now.
I don't think the 5900 is going to quite do it. It's going to be really hot.
It's
might be okay to prototype, but
well, we've ordered them, we've got them, they're being installed now. So
can a freeze spray handy.
Yeah. A TE cooler on it, right?
Right.
What's the smallest TE cooler I can get? This part's 2.5 millimeters square. It's a pretty small cooler.
You can get some pretty small ones.
Smallest one I have is about a half an inch on the side.
Yeah.
I see Jules' note about the bear. We had a bear walk into a house the next town over. They're awake.
Oh, yeah, this thing was laying on the grass just in front of the front porch, eating the suet, growling at the dog who wanted to go out. But
Oh, the dog would probably lose.
The dog is inside now. It's we didn't let it get anywhere near it.
Say, I put a link to the project status page, which I updated last weekend while watching Hamsai. And I want to make sure that I'm giving a adequate representation of where we are. This is easy to change any of these statuses: done, progress, pending.
Oh, okay.
So if your project is not properly represented, please let me know and I'll adjust it.
So what's the difference between in progress and pending?
Pending is you haven't done anything on it yet.
Oh, well, you can take, oh yeah, production, okay. So in progress means we have a real date, pending means we don't know.
Yeah. So it's
Is
kind of
pending
like
mean not started?
done, in progress, pending are the steps
Okay.
right now. And so
This
it's
looks-
either
looks like-
done or it has, we haven't done anything with it, and in progress is you're working on it.
It looks good, Dave.
I wanted to indicate that the magnetometer is, we're working on the production of it.
Right, right. And that's exactly right.
Yep.
Do we want to have the adapter board on there, or is that skunkworks?
Yeah, I think you might want to add that, Dave, if you want to
Okay.
put that underneath the data engine.
Okay.
I'm calling it the DE adapter board for
Yeah.
whatever that's worth.
And once these prototype boards come out, we'll update those as
Yeah.
at least done.
So the DE prototype board would follow the same as the data engine right now at this point.
Okay.
And actually you can for the prototype board, you can put NA for production because we're not going to production build those
Okay.
because they're just for testing.
Okay. Okay, very good.
Looks great, Dave. And so I have been talking with John Ackerman a little bit about the clock module carrier board also, which is like the last one. You might want to put that one on there also.
Okay.
It's not really part of the Tangerine SDR, but it's a use for the GPS timing module. And you can put that like underneath the VLF board because it's kind of like an ancillary project. And it's the design's in progress. Everything else is pending.
Okay. I'll add
And we
those.
think we got a pretty good mechanical layout so that we can actually build an enclosure for it, which would, in fact, if you're interested, I could show it to, I
Sure.
could share that if you have interest here.
Go ahead.
Let's get here. Hold on one second. I'm not a computer user, apparently. Okay, let's try this again. Okay. Make that full screen, move that over there, blah, 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 blah. Okay. Now I just got to figure out where all of my control buttons went. There they are under more. Roger Moore. Is that a Monty Python thing? Roger Moore. Anyway, not the actor. They make fun of him in some kind of skit. Okay, so if you can see this, this would be the carrier board, the large board, and we plug the clock module in down here.
Mhm.
And the PPS out, GPS antenna, and 10 megahertz reference in would go right in through the back. We call this the back. John and I went around and around. What's the back? What's the front? What's the top? What's the bottom? So I put labels on here because I can't ever remember which one's the top and bottom. So it's kind of a flat pack. Like consider an oversized cassette box is kind of the idea, with all of the IO coming out the front, back, left or right, nothing out the top, nothing out the bottom. So you can set it up on your shelf, and all the cables that kind of lay flat on the shelf. And we have 10 outputs, but we would probably want to use 8 outputs as programmable outputs, and then outputs 9 and 10 would be the 2 that you could get differential outputs from if you wanted those. And we're going to put a small microcontroller on the board with a USB port, and it's going to talk to the clock module and be able to program it to default state, or talk to your PC and let the PC program the clock module. And so this GPS USB down here will go directly into the clock module and talk to the GPS on the clock module. And this GPS, or pardon me, this USB up here will go into the microcontroller and talk to him. And then the microcontroller will talk to the clock module on their I2C.
I see.
And it looks, a side view looks like this on the bottom here, that the clock module will just kind of plug in and set on top of the module. And the idea would be to make the case a clamshell case. So what you do is, for every place there's a connector that goes through the side, you would make a U-shaped cutout in the clamshell case, and then the top would have a tab coming down that would come down and leave just the hole for the connector to protrude. So you could mount the board to the top half of the case, and the bottom half is just kind of a cover that goes on and screws in with some standoffs. So 2 pieces silk screened, and you probably only need to silk screen the top part on the top of the case, not on the sides, because you put the nomenclature right next to the connector that it is that's on the vertical side. So I think this makes the box pretty easy to manufacture.
Good.
And you don't have the problem of trying to fit connectors in from both sides in a box with holes in it that you can't possibly get connectors in. These would go, like I said, in little U cutouts, and then the opposite piece would fill in most of the U, but not all of it. And I'm trying to think. I've seen a connector. I've seen a box like this somewhere. I can't remember which radio used that kind of configuration. And I'm not a very particularly good 3D artist, so I can't really draw what I'm thinking of here. But that's what we're looking at anyway.
Looks good.
So I'm wondering if we might be able to use this. We might be able to put a dummy clock module on multiple data engines, multiple TangerineSDR receivers, and because you can make these all phase synchronous with the synthesizer chip, and you could just run them all out, one to each Tangerine, and you could have all of them synchronized to one clock, one master clock down here. Trying to plan ahead for the people that they always come up to me and say, I want to run 16 channels synchronously. Can you do that? So we're trying to say yes.
Yes.
But whether we'll actually be able to do it, I don't know. I don't know how close we're going to get to the channel.
I think Edis had a product that they called Octo Clock that did something similar.
Okay. Well, I think John has made things called the TAD, the distribution amplifier.
Yeah.
Yes, he did.
Yeah, but I don't think it's designed to distribute 10 megahertz, not 122 megahertz. Like,
yeah, it's a 10 meg.
Yeah, it's designed for 10.
Yeah. Not to say that we couldn't feed 10 megahertz in to every clock module and get them synchronized. So.
Yeah, when you send a lot of 122s out, interesting things happen.
How does the 1 pulse per second get distributed?
Yeah.
Because you're
Okay.
gonna want to.
Anyway, that's what we got here for the
Okay,
for the
Scotty, on the very bottom right of that drawing, you have the side profile view, and it has right and left, which appear to be opposite of the thing above it.
actually, is that right? Yes, you're right. Notice the top ones. Since it's not an X-ray view, they are opposite and they are correct. Right being on the left side, because I've done to get this view, I've turned the thing around and you're looking at the other end, but yeah, you're right. You're right.
Okay, no problem.
Hey, Scotty, I got a question.
Oh, that's better. Boy, that's great.
How about that? Is that okay?
That's good.
Yep.
I got a question.
Sure. Go ahead.
The clock module, I assume that's at the bottom of that board. There's a
It's not
round
right.
circle right above the PPS out that
Right.
doesn't seem to match the ones over on the left-hand side of the drawing.
This circle is the mounting hole for the clock module that is centered on this connector here.
But he's saying the one over on
The one over on the
main
top
assembly,
left is
upper
not the
left,
same.
is different.
Yeah,
Top left.
up in the upper left corner on
That one.
yeah, that one, the hole's in a different place.
Yeah, it is.
Oh, that's easy.
There you go.
Thank you.
That was because it was there and we moved it and I changed it in one place but not in the other. So
Boy, I wish we could change prototypes that easily.
the advantages of real-time documentation.
There you go.
Anyway, yeah, thanks for catching that. That's good. I'd missed that. And the right and left also. Notice that the left is on the right side, but that's okay. Because I'm doing it from the front view. So all right, so now let's make sure we do a save since we changed something. So all right. How do I go back to full screen here? Oh, there it is over there. Okay, I can stop that. Yes. So that's kind of exciting to get that done. And I've got the schematic partially, I've got it started and from the things that John gave me. And it's really straightforward. And I think I'll be able to get all the parts because they're mostly ballons and coils and things like that that match the output to the SMAs. So there may be hope yet. I know that the DE adapter, we've gone through it all and all of the parts are available, either the parts that we spec'd originally or exact replacements for them. And we're going to be buying the parts tomorrow. So we'll be able to tell the CAD guy, you're not going to have to go change anything because we couldn't get the part because we already bought them. So that's the theory anyway. We'll see what happens. I'm so skeptical. I expect to see at least another part be unobtainium tomorrow that I could get today. So, and the other thing, I don't know if anybody noticed this, but I put a little OLED display on this the data engine adapter, and I did that because I figured this is probably going to be our demo board for the first couple of conferences until we get all of our hardware debugged. So it'd be nice to have a flashy little screen. So there's going to be, and it turns out that I may not be able to get that particular screen. So it may be a TFT screen. It's a 0.9-inch screen. So I mean, it's like a little bitty thing like that, but it's color. So it will be kind of flashy to be on the board. Probably take more effort to get that screen working than to get the RF module working. And it's pluggable, so if you don't want to use it, you don't have to install it. But So that is that. I think after this, I'm going to retire from doing hardware because I'm sick and tired of not being able to get parts. Oh, wait, I have to do the DE Mark II before I do that, right?
Hopefully things will get better by then.
I hope so.
It's got to, right?
Well, I don't see how it can continue like this and be very effective. And I don't know, what I'm hearing is things may get worse before they get better, and I don't want to hear that.
No, I don't want to hear that either.
But then I did hear,
I read that today,
but I was, I forget who I was talking to today, but they were talking about the shipping companies are trying to work together to streamline the interface between trucking and shipping and railroads so that they can streamline the transfer of goods between the three carriers and try it, because I guess we have an antiquated system here compared to most countries. So I want to try and fix that, which would be great.
Mm-hmm. How would they fix it?
I don't know, just a matter of planning so that when the ships come in, they have trucks there to take the containers to the trains or whatever, so that they can be scheduled across all three.
Yeah, the problem in the US was the truck drivers had a very antiquated system. They had to bid on every load they wanted to move. And so apparently the truck drivers were basically sitting around twiddling their thumbs for 3 days, waiting for this whole bid process for every truckload to work out.
Yeah.
And so they had lots of trucks doing nothing.
And what I'd heard was they'd have loads that the truck drivers could pick up, but then they would drive them to where their destination was, and they'd get there and there'd be nobody there to unload them. So then the truck driver is sitting there going like this, and he wants to get paid and get another load and move on. And he's stuck with the load and he can't offload it. So
yes, apparently none of that's been automated. It's all manual, or it was.
Yeah. So this is mostly the trucking industry then that they're talking about.
Well, the interface between the two.
Yeah. So we'll see. I don't know. I heard something today about expecting food shortages, but I don't know if that's worldwide or if that's here that they're expecting that. But because they said the price of fertilizer has gone up so drastically that they're expecting there to be food shortages now because of the cost of fertilizer or the availability of it. So, geez, I don't know what to believe. I think I need to get my garden going and grow some tomatoes.
I guess they're expecting a shortage of equal signs. So any code that you wanted to write where you want to assign something to a variable, you won't be able to get that. There's going to be a backlog.
Hey, when I started writing software, we didn't have ones. We only had zeros. So it's the same thing.
Gosh.
No equal signs. Yeah, that's right.
Should I stop the recording now?
Yeah, you should. We're getting silly.
Yeah, I think it's about time.
Let's go back into a rag chew session.
That's right.